Welcome to Computer Programming with MATLAB. This is Lesson 1, Introduction to MATLAB. My name is Mike Fitzpatrick, and I'm coming to you from Vanderbilt University in Nashville, Tennessee. I'll be your lead instructor, and I'll be supported by Akos Leditsi and Robert Terrace. All three of us are on the faculty of Vanderbilt School of Engineering. And we put together a course whose purpose is to teach computer programming to people who have little or no experience with programming. The level of the course equals that of an introductory first-year college course. The length is 9 weeks, which includes 8 weeks of video lectures and 1 week for a final homework submission. If you follow along with us, try all the examples that you see step by step on the screen, take the quizzes and do the homework. Then at the end of these 9 weeks, you'll be able to program a computer. You'll be good at it, and you should have fun doing it. To program a computer, you have to use a programming language. The first languages were complicated affairs of strings of ones and zeros or cryptic code words and numbers. And then in 1954, all that changed. A language was invented that was much more like a human language. It was called Fortran. Its purpose was to make programming easier, especially for solving numerical problems. Since then, hundreds of such languages have been developed. And in the 1970s, a new wave of them began. The most successful of these were C, C++, Java, and C#. And they're still heavily used languages. They're used especially for writing very large programs, by which I mean programs with hundreds of thousands or millions of statements in them. These programs are the shrink-wrapped products used by non-programmers, things like word processors, spreadsheets, web browsers, games, operating systems, and the like. In the midst of this new wave, another language appeared called MATLAB, and that's the language we're going to use in this course. MATLAB's purpose was to make programming easier, especially for solving numerical problems. But you may have noticed that was exactly the purpose of Fortran. So have we come full circle? No, because MATLAB is far easier to program than Fortran. I know, I've used them both. So where did MATLAB come from? Well, it sprang from the mind of one person, an expert in Fortran, by the way, named Cleve Moeller. Professor Moeller was teaching students at the University of New Mexico to solve numerical problems with Fortran, and they were spending way too much trouble struggling with the language. So he invented MATLAB, and it soon became so popular that Moeller teamed up with an engineer outside academics named Jack Little to form a company to make it available to the world. They named the company The MathWorks. It was formed in California in 1984, and it had one product, MATLAB. Well, that company is alive and well today in Natick, Massachusetts, 3,000 miles from California. And today it has 100 products, all based on MATLAB, and over 1 million users worldwide. And it's taught in 5,000 universities, including Vanderbilt. MATLAB is clearly having a big impact on the world. And in 2012, the Institute of Electrical and Electronic Engineers recognized that impact by giving Dr. Moeller its Computer Pioneer Award. They give this award out once a year, and they named it for improving the quality of mathematical software, making it more accessible, and creating MATLAB. And that brings us to this course. Computer programming with MATLAB is our effort to add to the impact of Moeller's creation by using it to make computer programming more accessible to you. There's no required textbook for this course, but there is a recommended one. As you can see, the title is the same as that of the course, and Akos Leditsi and I are the authors, so it's no surprise that it's the one we're recommending. This is an ebook, no paper is involved. It's been used at Vanderbilt since 2013, and previous versions of it were used since 2000. The book is organized into 3 major parts, which in the iBook style are called chapters. This course covers Chapter 1 and 2. The remaining Chapter 3 covers subjects that are beyond the scope of this course, but you'll be able to continue through that chapter on your own after you've completed this course. The book is available online at cs103.net. You'll find 2 versions there, an iBook for Apple's iPads and Macs, and a PDF for any other device. And they cost $9.99 each. To make our textbook and our course more effective, we approach MATLAB programming as part of the discipline of computer science. Computer scientists have spent over 50 years developing a concise set of concepts and a consistent vocabulary to describe all aspects of computer programming. And in both this book and this course, we use those concepts and that vocabulary to introduce you to computer programming. This approach will give you an idea of how computer scientists think, and it'll make it a lot easier to learn MATLAB. Well, let's take a look at the iBook. I'm going to show it on this MacBook here, but the iPad has the same features. The only difference is that instead of clicking a mouse, which I'll be doing on this MacBook, you touch the screen on the iPad. So after you've purchased it and downloaded it, it should be in your iBooks collection. Let's find it here. There it is. I've got it under computer programming. And if we double click it, you'll see the book open up and an animation starts with some pretty music. Let's go back to the table of contents. Sometimes you have to click up here to get that table of contents to show up. Let's click this little arrow next to Getting Started. This is Chapter 1. And we see Section 1 of Chapter 1 and 2, Introduction to MATLAB, Matrices and Operators. We'll spend a lot of time near the beginning of this course right here in Matrices and Operators. So let's go there. We see a set of objectives over here in the red. That's always there for every section. At the bottom we see we're on page 33. Let's go to page 34. If you look around here, you'll notice some lowercase words in blue type. If we click one of these, let's click Matrix, we see a definition. A two-dimensional rectangular arrangement of numbers, also known as a two-dimensional array. And there's two links. One says glossary, one says dictionary. Let's click the glossary. That's the glossary of this book. And these are the, you might say, official definitions that will help you the most when you're trying to understand programming. The matrix definition has related terms here. You can click on these. These are actual links, and it'll take you to where they are. And here's a link that takes you to the first occurrence or the defining occurrence of the term in the text. Right back here where we were. Well, I showed you some of these red links before. I said that some of them link out of the book and some of them link to other parts of the book. Well, here's one that says in the previous section. Well, if I was reading a paper book, I'd have to flip back through looking for it. In the iBook, I just click on this. It takes me right back. And did you see that plot thing to kind of highlight there briefly? And it's still highlighted in blue. That tells you that's what you're looking for. So suppose I read about it and I see what I want. Now I want to go back. Well, where was I? Am I going to flip forward again? You go down here and the little highlight pops up. It says back to page 34. All you got to do is click that and you're back to where you were before. Highlighting and annotating are both easy too. Just click and hold the mouse while you slide over what you want. And maybe I wanted to put a note. I want to try this in MATLAB. And down here, I'm going to highlight that in pink. To see all your highlights and annotations collected together, click up here at the top of the window on this little page icon here. This section called Notes shows up. They're exactly the two highlights we just did, and it shows what page they're on. One last standard iBook study feature is found by clicking the Study button up here on the left corner. It'll give you the annotations like that. You can click here. Then we get to glossary terms. Flip the card, and it tells you the definition. And you can go to one after the other and try them. Loops. Loops is arguably the most important section in the book, and it's the section we spend the most time on in this course. Let's click Practice Problems down here. There. And it takes us to Practice Problems. You'll see the concepts from this section listed to the left. Practice problems are to the right, and you see these little question marks here. Question marks seem to show up on the odd-numbered problems. Well, those are where the answers are. So, for example, problem 21 over here, if I click this little question mark, I find the answer. Somewhere in this book is an example called surface plot animation. Well, over here at the upper left corner, if I click here, we see a little search icon. Let's click that. I'm going to search for that surface plot animation. Hey, it showed up right there. Let's go there. There's a play button here. Let's click that. No, that's kind of cool. But there's another version of this book, the PDF version. Once you've downloaded it, you can open it like any standard PDF with the free Adobe Reader or with Acrobat. There. And it's opened up in Adobe Reader. This version contains a verbatim copy of the text in the iBook, and it comes with the features of a PDF, including a table of contents over here with live links and highlighting and annotation. The same practice problems are there too. The blue highlights are still there on the glossary terms, but they're not linked to the glossary. Instead, we provide something called an index and glossary at the end. Let's go down here. Looks like a standard index, but each entry, in addition to having the page number of the definitive introduction of the term, also has a definition, and it's got those related terms that we saw before. And that's it for the textbook, both versions of it. One last comment about it. Like the course, this textbook is not merely an introduction to MATLAB. It's an introduction to programming using MATLAB. Okay, enough with the preliminaries. It's time to get down to business here. After you picked a textbook and downloaded it, downloaded MATLAB and installed it on your computer, you're ready to go. So what's next? Let's run MATLAB.